All right, so today we're going to be looking at solving systems by graphs and tables. Today you guys are going to be solving what we call systems of equations, and I'll show you what a system is here in a little while. However, the method we're going to use to solve those systems is something called graphing, and we're also going to be using some tables. Okay? All right, so let's go ahead and get started. On your notes at the very top, it says a blank is two or more equations comprised of two or more related variables. In that blank, I need you to write for me system of equations. System of equations. System of equations.
Can I ask that question now?
Yes.
When are we going to start using those things in?
Yes, we're going to start using those hopefully tomorrow.
Yay.
Tomorrow we'll use those to
Let's get tomorrow, but I need one.
Yes, ma'am. Yes, we're going to be getting out a little early on Thursday. No, not Friday, just Thursday.
I'm excited.
All right, system of equations. Now it says here it has two or more equations. We're going to keep it fairly simple today, and we're going to be looking at two equations. As you can see, they've given me an example here. This top piece is the first equation. This right here is the second equation. So notice there's two equations here. And in those two equations, they have the same variables. They both have an x, and they both have a y. This is what we call a system of equations. Two equations with two variables. Now, in this example, guys, they use an x and a y. Does it always have to be an x and a y? No. It can always be any other letters like an a and a b. Maybe it's going to be a d and an f. It just depends on what we're talking about. So it could be an r and an s. So again, all this is two equations with two variables. In this case, those variables are the x and the y. So anytime they ask you what's a system, it's two equations that has two variables. Two equations with two variables. Now, as I mentioned earlier, what we're going to be doing today is we're going to be using the graphing method. And in order to graph these equations, we're going to have to rewrite the equations in slope-intercept form. Now, that's the part I told you guys that some of you are still having trouble with, so you're going to have to pay extra careful attention today. You'll notice that's what they did over here. They took this first equation and rewrote it as this here. That is what you call slope-intercept form. They did the same thing to the second equation. They took that thing right there, and they wrote it in this form right here. It's called the slope-intercept form. We'll be doing the same thing today. We'll be taking our equations and writing them in slope-intercept form, which we've done in the past. That's not anything new, but some of you had some trouble with that, so you might have some more trouble today. All right, let's keep going here. Since we're going to be graphing two lines on the same graph paper, one of these three things is going to happen today. So remember, two lines on the same piece of graph paper. One thing that could happen is that the two lines can intersect, like I have right here. And that first graph that you see there. That's the first thing that can happen. The two lines can intersect. So I need you to write that down in the box form. The lines intersect. Lines intersect. Mm-hmm. And the reason that's important is because wherever those two lines intersect at, that is the point of solution, or the solution. Okay, so in this case, wherever they meet up, that is going to be the answer to our problem today. So the answers we have today are going to be in the form of an ordered pair. And this right here is usually what's going to happen. Most of the time, you're going to see the two lines crossing each other. You're going to have to tell me where they cross at. Most of the time, that's what's going to happen. However, another thing that could happen is the two lines that you graph could be right on top of each other, which is the next picture you see here. If those two lines are on top of each other, what that means is we're going to have an infinite number of solutions. In other words, we're going to have lots and lots and lots and lots and lots of answers. And rather than writing out all of the answers, because there's lots of them, usually what we do is we just use this little symbol right here. Anybody know what that little symbol is? Infinity. All right, that right there is the symbol that we use to show that there's lots and lots and lots and lots of answers. And rather than writing them all out individually, we just use that symbol right there. The last thing that could happen is that the two lines could be parallel. In other words, they don't touch each other. And if those two lines don't touch each other, like I have down here at the bottom, then what happens is there is no solution. Right here. If the lines are parallel, there is no solution. And if you're too lazy and you don't want to write out the words no solution, what you could do instead is use this little symbol right here, a 0 with the line. And that means the same thing, no solution or the empty set. So again, one of three things can happen. You can have no solution, which would be this one right here. You could have lots of solutions, which would be this one right here. Or you could have one solution. I'm going to put that right over here. One solution. And that would be an example of one solution. That's it, guys. Those are the only three things that can happen when you graph two lines on the same piece of graph paper. They can cross, they can be parallel, or they can be on top of each other.
What is that thing?
What? The red one? This was just a little star that I was trying to put there. That's just a star. All right, so now we're going to take a look at some specific examples. Well, I'll take that back. We're going to hold off on the examples. There's one other thing we've got to look at on the next page. On the next page up at the top, there's a couple of blanks that we're going to need to fill in here. It says here, systems of linear equations can be solved using a variety of different methods. The first one, which is the one we're going to look at today, is graphing or graphs. That's one way to find the answers, using graphs. Another way we can find the answers to our system is using the tables. We'll also look at that one today as well. These are the only two that we'll look at today. But there are other methods, and we'll look at those later on. We could also use algebraic method. DJ, you writing all this down? Make sure you're following with algebraic methods. And when I say algebraic methods, there's two specific methods that I'm referring to, and one is called substitution, and the other one is called elimination. And we won't get to those until probably Thursday or Friday. Today we're strictly looking at graphs and tables. And then finally, one other method that we'll see later on, probably not to the end of next week, is something called matrices. So all of these are different ways to solve what we call a system of equations. Different ways to come up with the answers. Today we're only looking at the first two, graphs and tables. I know what some of you are thinking, well, which one is the easiest? Well, that's going to depend on you guys, and it's also going to depend on how the problem is written. If it's written one way, graphs are easier. If it's written another way, sometimes substitution is easier. If it's written another way, well, then maybe elimination is easier. It all depends on how the problem is written and what you guys can do, what you're good at. All right, so let's go ahead and get started here. Now, there's a lot of stuff in there. Rather than reading all of that stuff to you, I'm going to go ahead and jump into an example, but I do want you to fill out up at the top here. Solve systems graphically. That's what we're going to be looking at today. We're going to look at how to solve systems graphically. How do you use the graphs to determine your solutions? And all right, they give us a couple of steps here, but like I said, rather than just reading each one of those, I'm going to go jump into an example so you can see how this is going to work. All right, so let's take a look at that example here. Example number one, you've got two equations. That is what you call a system of equations. Notice there's two equations, and they've got two variables, an x and a y. So the first thing I'm going to do is take this first equation that you see up here, x minus 4, and we're going to graph it. So on your graph paper, we're going to graph x minus 4. So watch this. So this is the graph of x minus 4. Now, if you've already forgotten, let me show you something here, guys. This minus 4 that you see back here, That right there is the y-intercept. That's our starting point. So I need you to put a dot right here at -4. And I know the graphs are kind of hard to reach. Do the best that you can. Start at -4. To get the other points, you look at the number in front of the x, and there is a number, you just can't see it. Anybody know what the number is? 1. However, since that number in front of the x is called the slope, and we use m for slope, we said that slope was defined as rise over run, which means we need a fraction. So I'm going to make the 1 a fraction by putting a 1 underneath. 1 over 1. So here's what that means. I need to rise 1 and then run 1. So from my y-intercept, I'm going up 1 and then over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Remember, we said the more points we put, the straighter the line is. So I want you to do the same thing. Put as many points on there as possible so that when you draw your line, it's straight. We don't want any crooked lines here. Otherwise, we could get a wrong answer. Do the same thing on the other one over here. We did this before. We can go down 1 to the left 1. Down 1 to the left 1. Down 1 to the left 1. The more points you have, the straighter your line is going to be. So what we've done up to this point is graph the first equation. This is what we just graphed. Now what we're going to do is we're going to take that second equation and we're going to graph it on the same piece of graph paper here. So let me graph this one. All right, so there's the other one. Again, let me point out a couple of things for you. Notice the 10. That's our y-intercept. That's where we're starting at. Notice this time in front of our x, it's a -1. And since I need a fraction, I'm going to write that as a -1 over 1. So TJ, since -1 over 1 is our fraction, or our slope, what is that telling me to do? What's the -1 telling me to do? Go up 1 or down 1? Down 1. And how many to the right? 1. So from my y-intercept, I'm going down 1 to the right. Down 1 to the right. Down 1 to the right. Continue doing that until you run out of room. You can't do that anymore. The more points you have, the straighter your line's going to be. Down 1 to the right. Down 1 to the right. Down 1 to the right. When you get done here, you should see 2 lines on that graph paper. 2 lines. One of 3 things just happened here, guys. Those 2 lines either cross each other, they're parallel to each other, or they're on top of each other. All right. So what the heck just happened? They cross, which means we have one answer. Where's the answer? Right here, guys. Highlight that point for me. Darken it in. That's the important piece. This right here, where they intersect at. That thing right there is your solution. Where do they intersect at? What is that ordered pair there that I just darkened in? Melissa, help me out here. What is that point that we just darkened in? What's that ordered pair? 7, 3. That is correct. 7, 7, 3. So what I want you to do is right next to number 1, real big, we're going to write the ordered pair 7, 3. And that thing right there is our solution. That's the answer that we're looking for. That right there is the solution to our system. It's the only ordered pair, that makes this equation true, and it also makes this equation true. No other ordered pair will do that. Only that one right there, 7, 3. Now I'm going to show you a little trick because some of you guys are going to have trouble graphing this. So I'm going to show you a little help you can get from your calculators. Everybody go to your calculators now. Reset them for me first. Second plus, 712. Second plus, 712. Reset those calculators. Once you reset it, I want you to go to y equals on your calculator. And I'm going to be walking around checking your graphs here in a minute, guys, so make sure you're following with me. Go to y equals. And on the very first one in y1, what I want you to do is I want you to type in x minus 4 for me. Type in x minus 4. Then what I want you to do is go right below that one. And in y2, I want you to type in the other equation. I want you to type in a negative x plus 10. type in negative x plus 10. Make sure you're using the negative sign and not the minus sign when you type that in. Once you have them both in there, I want you to hit correct. Hit correct. What you should see is the same thing that we put on our paper here. Are y'all seeing the same thing that we put on our paper? If you not, then you type something in wrong, because you should see the same exact thing that we put on our paper earlier. So how many of you see the same thing right now on your calculators? I want to see a show of hands. See the same thing? All right. Go back to y equals and see what happens. Make sure you got x minus 4 on the first one. Okay. You got x minus 4 on the first one. Oh, you don't have it there. You got second x minus 4. All right, go to the next one. And I want you to type in negative x. Negative down there. Plus 10. Nice. All right, so now that we see the same thing on our calculator as we do on our paper, here's the cool thing about this, guys. The calculator will actually tell you where those two lines are crossing at. And I'm going to show you how to do that next, so make sure you follow with me here. On your calculator, everybody still got your graph showing right now, right? I need you to go to seconds. Hit the second button. Then I want you to go up to the top and find the button that says trace. What does it say at the top of your screen right now? Calculate, right? It says calculate. What we're going to ask the calculator to do is find where these two lines intersect. So what is the one we're going to tell the calculator to do to find intersection? Number 5. So select number 5 for me. Intersect. Now here's the catch. It doesn't give you the answer right away. You're going to have to hit enter 3 times. Hit enter 3 times. 1, 2, 3. And down at the very bottom of your calculator, you're going to see 2 numbers. What are the 2 numbers you see down there at the bottom of your calculator? 7 and 3. Well, guess what? That 7 and 3 is the same thing that we got for our solution here. Okay? So we can both do it on our paper, or we can ask the calculator to do it for us and find that point of intersection as well. Okay? So this is how we use our calculator or graphs to find the solution to this system right here. Now remember, I said I was showing you 2 ways. One with the graph and another with the table. So let me show you the table part. Everybody go to your tables now. Second graph. Everybody go to your table, second graph. And I want you to go down until you find 5 underneath the x column. What are the 2 numbers you see right next to that 5?
5, 1, 5.
What is it?
5, 1, 5.
1 and 5, right? Okay, what do you see right next to 6?
2
and 4.
2 and 4. What do you see next to 7? 3 and 3. Next to 8?
4 and 2.
4 and 2. And next to the 9?
1.
What's that?
5 and
5 and 1. Everybody agree with this? This is what you're seeing on the calculator?
1. Yes.
If for some reason you cannot see where these 2 lines intersect on your graph, you could always go to your table. You just got to know what to look for in your table. Now remember, we said the solution was 7, 3. So where am I going to find that in my table? Well, if you look in the table, there's only one spot where the y value repeats itself. And that's going to be right here. Notice how this y and this y are the same exact number here. That right there is letting me know that my solution is going to be the order pair 7, 3. In other words, it's the same order pair twice. 7, 3 for the first equation, 7, 3 for the second equation. That's the way we can find the solution in our table. Just find the matching y values. Notice that's the only spot where you're going to find the y values that are exactly the same. No other place where you find that happen except for this specific spot right here. Okay. All right, so there's one example. Let me go ahead and do another one with you guys. Let's take a look at the number 2 here. Y equals 3 minus x. Now, I don't like the way they have that one written, so let me fix that real quick. This right here can also be written as y equals negative x plus 3. I just like the x first. It just makes it easier for me to graph my slope-intercept point. So this is the same thing as this here. They mean the same thing. I just switched the negative x and the 3. So I like the x first. All right, so I want to graph y equals negative x plus 3. So where do I need to start at, guys? I'm going to graph this on our phone. We should start at positive 3. So put a dot at positive 3 right here. The slope is negative 1. But I need a fraction, so I'm going to make it negative 1 over 1. So just like earlier, we're going to go down 1 to the right, down 1 to the right, down 1 to the right, down 1 to the right. The more dots you have, the straighter your line's going to be. Remember, you can get some other points over here by going up 1 left, up 1 left, up 1 left. All right, so that right there is this graph right here. That's our line. You should be graphing this on your paper as well. So that takes care of the first one. Now what we're going to do is we're going to graph the second equation. Notice the y-intercept this time right here is at positive 1. So this time I'm starting right here at positive 1. Notice the slope of this line is 1. That's the number in front of the x. However, since I need it to be a fraction, I'm going to write it as 1 over 1. So what we're going to do is we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. The more points you have, the straighter your line is. So when I get done with this, my graph should look something like this right here. Notice again, notice how these two lines intersect each other. They cross. So what I want to do is I want to know where are they crossing? What is this point right here where they cross at?
1, 2.
1, 2. Guess what? That 1, 2 is our solution. It's our answer. So write that real big for me right next to number 2. That's our solution. Now I'm going to show you how to do the same problem using your calculator, because tomorrow I'm going to give you an assignment. Half of the assignment you'll have to do it by hand. The other half of the assignment you're going to be able to use your calculator. So I'm going to show you both ways here. All right, so let's go back to our calculators, and let's go to y equals. Everybody go to y equals on your calculators. And in y equals, we're going to type in the equation that we got up here earlier, negative x plus 3. So type that in your calculator, negative x plus 3. Negative x plus 3. Negative x plus 3. That's in y1. Negative x plus 3. Then what we're going to do is in y2, we're going to type in the second equation, which was x plus 1. So type in an x plus 1 form. X plus 1. Once you have both equations typed in, I want you to hit graph. Hit graph. Your graph should look exactly like the one we have on our paper. Is that the same thing you see on your paper? Yes. How did we get it to show us where they intersect at? Do you remember what we did? Second trace. So go to second trace again. Second trace. But which number did we use before we hit enter?
5.
Number 5. So make sure you select number 5, intersection. And then hit enter 3 times. Enter, enter, enter. And down at the bottom of your screen, you're going to see 2 numbers, which should match up with the 2 numbers that we have up here. And those 2 numbers are 1 and 2. So again, tomorrow on your assignment, I'll be showing you, or you'll be working it both ways, by hand and using the calculator. So I want to make sure you got it both ways. Last thing I need you to do is go to your table form. Second graph. 0. What do y'all see right next to the 0?
3.
What's that?
Yeah, 3.
3 what?
1.
1. What do y'all see right next to 1?
2.
2 and 2. Right next to 2 you see a
1 and 3.
1 and 3. Next to 3 you see a
0 and 4.
0 and 4. And finally right next to 4 you see a negative what?
Oh, wait.
next to 4?
Negative 1,
Negative
5.
1, 5.
Negative 1 and positive 5. Is that right? Okay. Now remember, you can find the solution in the table as long as you know what you're looking for. If you look at the table that I've written, notice the only place where we have the y's that repeat are right here. Notice the same y value shows up twice, which means my solution to the system can be found right here. It's going to be the order pair 1, 2, because 1, 2 shows up in the first equation, and 1, 2 also shows up in the second equation. So this is how we know where to find the solution within our table. All right, so that takes care of number 2. We got 2 more that we're going to look at real quick here. 2 more. Take a look at the special case, and we're looking at number 3. This right here. I want to graph y equals 1/2 x minus 3. So, in order to graph that, I'm going to take this and graph it. Now notice here, the y-intercept, negative 1, negative 3 over 2 is the same thing as negative 1.5. It's the same thing, which is what I have right here, negative 1.5. That's where I'm starting at, negative 1.5.
Because I got to stop the game. I gotta go to college.
You driving by yourself?
No, taking a bus.
Oh, you catching a ride?
Yes, I can.
You on varsity?
No, okay.
JV. They let freshmen on JV. Go. Notice the slope on this graph is 1 over 2, which means we're going to go up 1 over 2, up 1 over 2, up 1 over 2. So this is the graph of y equals 1/2 x minus 3. Now I'm looking at the second equation. I don't like the way they have that one written either, so I'm going to change it up a little bit. Notice we're taking the top equation and dividing it by 4, which really means you're taking each part and you're dividing it by 4. So I'm taking the 2 dividing it by 4. I'm also taking the 6 and dividing it by 4. Which if I do that, 2 over 4 reduces to 1/2. 6 over 4. 6 over 4 reduces to 3 over 2. So I went from this one to this one. I didn't like the way that one worked. So what is the graph going to look like? Well, let me go ahead and do that. See what the graph looks like. And there it is. There's my new graph. I don't know. You tell me. Where's the other graph, guys? It's right on top of it. Why is it right on top of it? Because they're the same. So notice the equations that I have are exactly the same. This thing I have here is exactly the same thing I have over here, which makes sense that one would be on top of the other. So, the fact that you only see one graph, well, you got to keep in mind that one's on top of on the other. Okay, so this is why you're only seeing one graph. So what did we say earlier when that happens? How many answers are we going to have whenever you have one line on top of the other?
It's called
It's on the front page, guys. And on top of each other.
infinite.
There you go. Infinite solution. What symbol did I have you guys use for infinite? A little sideways 8. Okay, so that's what we're going to use for number 3.
Mine's like a little fish.
And again, the reason that is the answer is because we have lines on top of each other. Lines on top of each other. Okay, we got one more example that we're going to look at together, and then I'm going to give you a chance to work some of these on your own. The last one, number 4. Again, I don't like the way they have this one written, so I'm going to change it a little bit. We're going to divide everything by 2. So since there's a 1 in front of the x, it's 1 divided by 2. And since that has a 3 there, we're going to divide that by 2 as well. So this right here is what I want to graph. So let me see here. What does the graph of that look like? Here it is. There's the graph. Notice that I started at 1/2, which is the same thing as 3 over 2. Notice that I went up 1 over 2, up 1 over 2, up 1 over 2. So go ahead and do the same thing on your graph paper. That's the first equation. I don't like the way this equation is written either. So I'm going to change that one as well. I'm going to divide everything by 4. So now I've got 2 divided by 4x and 3 divided by 4. You'll notice 2 over 4 is the same thing as 1/2. So I'm just going to reduce that fraction. So this is the same thing as that thing. So let's see what happens here this time. All right, there's my new graph. Notice on this graph I started at -3/4. That's right here. Notice that I went up 1 and then over 2. Up 1, over 2. That's what this part is right here. What do you notice about the lines this time? What are they doing this time? They're what? And what does it say on our first page? Whenever they're parallel, what kind of solution? No solution. And what symbol did we use for no solution? A circle with a line through it. Alright, so here's what it comes down to, guys. Anytime you see parallel lines, what should you be doing for parallel lines? Come on. What do you do for parallel lines? 0 with the line through it. What does 0 with a line through it mean? No solution. What if the lines are on top of each other? What are we going to use for lines that are on top of each other? The infinite solution. If the lines cross each other, all you got to do is tell me where they cross each other. All right. In this case, they cross at the order pair 1, 2. All right. So that's going to take us through our notes. What I need you guys to do now is take a look at the next page or the last page